Introduction 1. Hardware description languages, HDLs, exist to describe hardware. In this they differ from traditional programming languages, which generally exist to describe algorithms. Programming languages such as C grew up with computers that were constructed with a von Neumann architecture, meaning that they had a central processing unit, CPU, connected to memory that held both instructions and data. The CPU also controlled peripheral elements such as displays, keyboards, long-term storage, networking, etc. The fact that there was one CPU meant that programming languages developed to describe procedures that consist of a sequence of operations performed in a serial manner to the data in memory or on the peripheral elements. Contrast this with typical hardware systems where there are many individual components that all operate simultaneously. To properly describe hardware, one must be able to describe both the behavior of the individual components as well as how they are interconnected. Hardware description languages have two primary applications, simulation and synthesis. With simulation, one applies various stimuli to an executable model that is described using the HDL in order to predict how it will respond. Simulation allows you to understand how complex systems behave before you incur the time and expense of implementing them. Synthesis is the process of actually implementing the hardware. Here the assumption is that the HDL is used to describe the hardware at an abstract level using component models that do not yet have a physical implementation, and that synthesis is the act of creating a new refined description with equivalent behavior at the inputs and outputs that uses components that do have a physical implementation. The goal for HDLs used for simulation is expressiveness. They should be able to describe a wide variety of behaviors easily. The goal for HDLs used for synthesis is realizability. They should only allow those behaviors that can be converted into an implementation to be described. As such, if a single language is used for both simulation and synthesis, then generally synthesis only supports a relatively constrained subset of the language.